In this video, we will learn about organometallic reagents. We will focus on two important types of reagents. One is the organolithium reagent and the another one is the organomagnesium reagent. So the R group here can be an alkyl group or even it can be an aryl group. And the halogen here can be the fluorine, bromine or iodine. So this reagent which contains the lithium, we call it as organolithium reagent, and the one with the magnesium we can call it as organomagnesium reagent. The organomagnesium reagent is also known as Grignard reagent. So this is very important name for organomagnesium reagent. They are generally known as Grignard reagent. So these two reagents can be used for carbon-carbon bond formation. For example, if you take a cyclic ketone and you treat this with an organolithium reagent, and after the reaction you added water, as you know the water is a source of H+, so you will convert the ketone into an alcohol and you will generate a new carbon-carbon bond. So this is the new carbon-carbon bond. The same reaction we can also carry out with the Grignard reagent. So you use the RMgX and later you add the water. So you will generate the corresponding alcohol with a new carbon-carbon bond. So this is the new carbon-carbon bond. Now let's have an understanding how this organolithium or the organomagnesium will generate a new carbon-carbon bond. So if you see the starting material, so you have a carbonyl group here. So I will write the carbonyl group containing a carbon and an oxygen. So this is a pi bond. And if you see the organolithium reagent, so I am taking an organolithium reagent. For example, I am taking a phenyl lithium. So phenyl lithium is just, this is the phenyl group which is attached to the lithium. So it has again a carbon here and a lithium here. So it is a carbon lithium bond. So it is a sigma bond. And if you see the electron negativities of these atoms, the carbon has 2.5, oxygen has 3.5. Again, we have the carbon which has the 2.5 and lithium which is 1. So if you consider the carbon and the oxygen, you can see that the oxygen has the higher electron negativity. That means the oxygen will pull the electron towards itself like a tug of war, and the oxygen will be the winner. So the oxygen will gain a partial negative charge and the carbon will gain a partial positive charge. And if you see the carbon lithium bond, the carbon is more electronegative. So here the carbon will pull the electron towards itself and the carbon will gain a partial negative charge and the lithium will gain a partial positive charge. So we can say here the pi bond is more polarized towards oxygen. Here in the carbon lithium bond, we can say the sigma bond is more polarized towards carbon. If you take a nucleophile, which can be a negatively charged species or a species with lone pairs of electron, that means they are electron rich species. So the negatively charged nucleophile will attack on the positively charged carbon. This is because the opposite charges attract. So once it attack on the carbon, the C double bond oxygen will break and this bond will go to the oxygen. So we can say that this carbon nucleophile will attack here. So the nucleophile attacks here. And suppose you have an electrophile, that means a positively charged species, and you have the carbon here in the negatively charged state. So this carbon lithium bond will get polarized and this bond will attack the electrophile. So you have to remember, always we will draw the arrow from the negatively charged species to the positively charged species. So in this case, we have to draw the arrow from the bond, not from the carbon. This is because we are telling like the bond is more polarized towards carbon. So we can say here the electrophile attacks. So let's have a detailed understanding of the mechanism of this reaction. So I take the ketone and we have the lithium reagent and we added the H plus at the end of the reaction. So you will generate the corresponding alcohol and this is the new carbon-carbon bond formed. Now we will draw the charges. So here we will get a positive charge and here we have the negative charge and again the lithium is positive and here we have the partial negative charge. So we will expect the R lithium bond will attack the carbonyl carbon and this bond will cleave to the oxygen. So what you will generate is the oxygen with a negative charge and the R group here and the lithium will get a positive charge which is close to the O minus for stabilization. And you have the water. So this O minus will attack the hydrogen of the water and you will generate the corresponding alcohol. And you will generate the OH minus, right? So this will react with the Li plus and you will generate the lithium hydroxide as the side product. So now we can see one example with an aldehyde. So I take an aldehyde here and I treat this with a lithium reagent. For example, I treat with vinyl lithium. So this is the vinyl group and this is the vinyl lithium. And again, I added the water. So what you will get? You will get the OH here and you generate a new carbon-carbon bond. So this is the new carbon-carbon bond. And you have the hydrogen here. So if you write the mechanism, so first you have to write this is the positive. So this is the negative center. Again, you have here the positive. So here you will generate the negative. So you will expect this bond will attack the carbonyl carbon and this will cleave and generate the O minus. So what we will get? We will get the O minus here and we have the hydrogen here and you will generate this one. So once you add the water, so the O minus will take this hydrogen and you will get the final product with lithium hydroxide as the side product. We can also try some examples of Grignard reagent. For example, I take this starting material. So I added the phenyl magnesium bromide. This is our Grignard reagent and we treat with water. So we will get the product. So this will become the alcohol and you have the new carbon-carbon bond which is attached to the phenyl. So this is your new carbon-carbon bond. First we put the charge. So delta positive, here delta negative Again, you will get here a delta positive in the magnesium. Here you will have a delta negative. So what we will expect? So we have the phenyl magnesium bromide. So this is delta positive, delta negative. So this bond will attack here and this bond will break. So you will generate the O minus and you have the pH and you have the remaining magnesium bromide with positive charge that will stabilize the oxygen, and you add the water. So this O minus will attack here and you will generate the OH minus. So you will get the product OH, the new carbon-carbon bond here with byproduct a magnesium salt. So this is the byproduct. Let's try one more example. So I have take here an aldehyde. So I treated with a Grignard reagent. So this is a isopropyl group. So it is isopropyl magnesium chloride. So this is the Grignard reagent and we treat with H plus and water. Here the delta positive, delta negative. Again you have the delta positive and here the delta negative. So this carbon magnesium bond will attack the carbonyl carbon and this will cleave. So what you will get? You will generate the O minus here and you have the hydrogen here and you have the isopropyl group here and you added the water. Again this attacks here and this attacks here and you will get the final product. So this become the OH and here you have the hydrogen and you have the isopropyl group. Also you will observe the magnesium salt.